Hi there, welcome to Labster. In this lab, we can amplify, separate, and isolate DNA fragments. Today, you are on a mission to find out who stole your peanut butter. You have a DNA. This simulation uses voice. Using the lab. Perfect. Electrophoresis is a way to separate molecules, including DNA, by size. Molecules of the same size will form a band in the gel that can be visualized with dyes that bind to the DNA. Before we start, pick up a lab coat to wear it. Raise your lab pad for more info. Find a glove box and click on it. Great. Your colleague in the lab has already amplified the DNA by PCR. Your mission is to find out which sample matches the DNA. Let's go to the electrophoresis workbench so you can check out an agarose gel has already been prepared and placed into the gel electrophoresis machine. Check it out and look at the numbered wells. This is where you will load the samples in a moment. When you are ready, use the pipette to add the DNA ladder to well 1. What is the function of a ladder in gel electrophoresis? Amazing. A standard, or ladder, contains DNA molecules of a known size. By comparing the position on the gel of the DNA molecules in the sample to the position of the known fragments, you can estimate their size. Add the crime scene sample to well 2. You need to have a tip on. Great, now add the sample of suspect 1 to well 3. Finally, add the sample of suspect 2 to well 4. Great job! The DNA is now loaded into the gel. Next, we will turn on an electrical current that will cause the DNA to migrate through the gel. Click Start to begin the electrophoresis. Electrophoresis is used in biotechnology to separate macromolecules, such as proteins and nucleic acids, based on their size. The sample contains a mixture of molecules, in our case DNA molecules, of different sizes. The sample is mixed with a dye that binds to DNA to visualize the bands and loaded into a gel, a network of polymers, such as agarose or polyacrylamide. Electrodes are placed at each end of the gel to generate an electrical field. This creates a current that will be the driving force for separating the molecules. The gel now has a negative and a positive pole. As a result, charged molecules will migrate through the gel. Nucleic acids such as DNA and RNA are negatively charged due to their phosphate backbone. A buffer is applied to the system to provide ions that ensure a current flow from anode to cathode. The negatively charged DNA will migrate towards the anode. The gel acts as a molecular sieve. It hinders the movement of large DNA fragments more than the movement of small DNA fragments. This results in the separation of the DNA fragments according to their size. Where on the gel will the largest DNA molecules be, and why? Indeed, all the DNA molecules have a negative charge and migrate towards the positive pole. Smaller DNA molecules can move more easily through the gel matrix and will therefore cover a larger distance and be found nearer to the bottom of the gel compared to larger molecule. How are DNA or RNA molecules visualized on the gel? Indeed, to visualize the DNA or RNA molecules, a dye that binds to nucleic acids is added. Typically, the nucleic acid dye complex is fluorescent while the unbound dye is not, so DNA or RNA molecules of the same size appear as a band on the gel. Alright, the agarose gel experiment is now complete. DNA molecules of the same size have migrated the same distance and thus form a sharp band. Typically, you will need to transfer the gel to a transilluminator in a dark room that will excite the DNA dye complex with UV light. This will cause the bands to show up as fluorescence. In the virtual lab, we can show the bands directly in the gel tank. Click on the electrophoresis machine to have a closer look at the gel. Based on the band patterns, which suspect sample matches the crime scene sample and therefore belong? Are you sure? Click on the electrophoresis machine to have a closer look at the gel. Based on the band patterns, which suspect sample matches the crime scene sample and therefore belongs to the thief? Indeed, the band. Nice job. Let me ask you one last. Thank you for your feedback. Your score has been saved together with your 100%